be looking at 6E today from Unit 3 and 4 of the Methods textbook of Cambridge. So we'll be learning to solve trigonometric equations. So this is not new. This is something that we have covered in Unit 1 and 2, but we'll be applying it with you. So if I've got this question here, it says find the values of sine theta is equal to 0.4. For theta, elements are between 0 to 2 pi. So I'm only really caring about 0 here to 2 pi here for my x values. So the first thing I need to think about is what does it mean to have 0.4 here? Well, that's our y value here. So the first thing I need to be thinking about is where is it crossing in terms of the quadrants. So at pi 2, it ends quadrant 1, pi 2 to pi is quadrant 2, pi to 3 pi over 2 is quadrant 3, and 3 pi over 2 to 2 pi is quadrant 4. So we can see that it's crossing in quadrant 1 here and quadrant 2. That's the first thing we need to be thinking about. Now, we just need to find out what our x value is or what our theta is. So what is our angle? So to do that, we are just going to use the inverse, so sine -1, and that will give us our x value in radius. So our radius is 0.4115. The next step is we need to look at our two solutions between 0 to 2 pi. So this angle here will be 0.4115, but this angle will, in terms of radius, will be pi take away 0.4115. So we've got two solutions there. Same thing with this question here. It says find the values of cosine x is equal to -half. So we need to think about the cosine starts at 1. So we need to think about where -half is, which is over here. Again, if we're thinking about 0 to 4 pi, then that means we have it in quadrant 2 here, because pi 2 to pi is quadrant 2, and pi to 3 pi over 2 is quadrant 3. Now, we know from this point to this point is adding a period. So literally, we are just adding 2 pi. Likewise, from this point, once we found it, we'll be adding 2 pi to get to here. So I like to think about it as a unit circle. It makes it so much easier. We know it's quadrant 2 and quadrant 3. So whatever our value is that we find for x, we'll be taking it away from pi and adding it to pi. Okay, so for this question where we got, now that we know it's in quadrant 2 and quadrant 3, we are just going to solve by finding the inverse. So the inverse means x will be equal to cosine -1, -1/2. So to find x, I'm just doing the inverse of -1, 0.5. And then that will give me pi over 3. So that is what this part here would have been, pi over 3. Now I know it's pi over 3 because of this area here is always positive. I will then think about the negative here, which is what we are doing here. We are going, okay, well, we know it's in quadrant 2, so I'm going pi take away pi over 3, and that gives me 2 pi over 3. Likewise, I'm doing here pi plus pi over 3, and that gives me 4 pi over 3. So now I know these two. I'm going to use them by going across another period. So to get from here all the way around, I'm adding 2 pi. And that gives me 8 pi over 3. And likewise, I'm adding 2 pi from this point. So that'll be 4 pi over 3 plus 2 pi. And that gives me 10 pi over 3. For the next question, apologies, that's listed. It's not animated. Find the values of cosine x is equal to -√2 over 2 for x elements of equal to 0. So x is equal to or greater than 0 and equal to and less than 4 pi. So again, I just want to look at our graph. A basic cosine of x, it shows us that it's going to be hitting on quadrant 2 and quadrant 3. So that is our focus of our unit circle. Again, I'm just wanting to find what is our value right here for x. So to do that, the first thing that I'm going to do is use a calculator to find the reference angles, and that's using cosine -1, the inverse. To do that, I'm just going to plug it in and I will get pi over 4. So now I know it's pi over 4. To work out what this will be, it will be pi take away pi over 4. Again, I'm using this unit circle here, pi, to get to quadrant 3. I'm adding pi over 4 this time. So that gives me 3 pi over 4 and 5 pi over 4. The final step is because we're looking at 4 pi, I need to do a full period to get to the next one. So I'm just adding 2 pi to both of these. So 3 pi over 4 plus 2 pi is 11 pi over 4. And 5 pi over 4 plus 2 pi is 13 pi over 4. We're going to find the values of the square root of 3. Sine x minus 1 is equal to 0 for x elements that of x is equal to or greater than 0 and equal to and less than 2 pi. So the first thing that we need to be thinking about here is we want to get x by itself. So I'm going to add 1 and square root 3. Again, I'll find the inverse in a minute, but the first thing here is it's positive, and we know sine x is positive in quadrant 1 and 2. That's what we will be focusing on, those quadrants. The next part is I'm just going to draw a picture so we can visualize it. Let's look at the inverse. What is the inverse of sine x equals 1 square root 3? That will give us x is equal to sine inverse 1 over square root 3. And putting that into a calculator, I got 0.615. Now, x for quadrant 1 will be 0.615, but for quadrant 2, I need to start off with pi and take away 0.615.